Welcome to AgTech Digital as we explore modern cucumber farming from greenhouse seedlings to advanced pickle production systems. Careful soil preparation balances nutrients and creates loose planting beds that support strong roots and consistently high cucumber yields. Greenhouse germination maintains ideal temperature and moisture, helping delicate seedlings develop into healthy young plants with strong growth. Vertical trellis systems support vine growth, maximize greenhouse space, and keep cucumbers clean above the soil. Bright yellow flowers bloom along the vines, marking pollination and the beginning of healthy fruit development. Commercial beehives encourage natural pollination, producing uniform cucumbers and improving overall crop productivity. Small cucumbers grow rapidly after pollination under automated drip irrigation and balanced nutrient feeding systems. Hand harvesting protects fresh cucumbers from bruising, preserving their firm texture and smooth, attractive appearance for premium markets. Fresh cucumbers are washed and coated with natural food-grade wax to maintain moisture and extend shelf life. Automated packing machines place cucumbers into ventilated cartons, preparing them for efficient refrigerated transportation and marketing. For pickle processing, heavy-duty harvesters collect thousands of kilograms of cucumbers from large fields every hour efficiently. Rotating pickup fingers gently remove cucumbers from the vines, transferring them onto internal sorting conveyors for rapid handling. Continuous unloading into haul trucks prevents downtime, allowing uninterrupted harvesting throughout the busy production season. Fleet trucks deliver freshly harvested cucumbers to the Mount Olive processing facility for immediate processing. Hydraulic dumping systems wash cucumbers in turbulent water, removing soil and filth without damaging the delicate outer skin. Vibrating roller sorters set cucumbers into uniform sizes, ensuring consistent fermentation and high product quality. Large outdoor fermentation tanks hold cucumbers in salted brine, where natural bacteria slowly transform them into flavorful pickles. Salt levels, pH, and temperature are carefully monitored throughout fermentation to achieve the ideal crunch, texture, and flavor. After fermentation, pickles are rinsed with fresh water before entering automated cutting. High-speed rotary knives slice pickles into uniform chips, spears, or ribbon slices for commercial packaging. Empty glass jars pass through automated hot water washing systems, ensuring complete sterility before reaching high-speed filling stations. Mechanical packing fingers place exact amounts of sliced pickles into moving glass jars with remarkable speed and accuracy. Hot brine infused with dill, garlic, and spices fills every jar, preserving crisp flavor and extending shelf stability. Vacuum capping machines apply metal lids with steam, creating airtight seals that protect freshness and prevent bacterial growth. Thermal pasteurization tunnels heat-sealed jars, eliminating microbes while preserving crisp texture and fresh flavor. Powerful air blowers remove surface moisture from cooled jars, preparing them for automated labeling. Rotary labeling machines apply brand labels smoothly around every jar at high production speeds. Advanced optical vision systems inspect every jar, rejecting underfilled, damaged, or poorly sealed containers automatically. Robotic arms load finished pickle jars into cardboard cases, preparing them for palletizing and warehouse distribution. Automatic pallet wrappers secure stacked cases with stretch film, ensuring stability during commercial freight transportation. Electric forklifts stack finished pickle products in large distribution centers, ready for supermarkets across domestic and global markets. From greenhouse seedlings to pickle jars, modern agriculture produces crunchy, flavorful pickles enjoyed by millions every day. Next, we explore peanut production, examining unique soil conditions and modern harvesting techniques behind this important crop. Peanuts grow best in well-drained sandy loam soils with ideal pH, allowing underground pods to develop successfully. Large 32-row planters sow thousands of treated peanut seeds every minute at accurate depths and row spacing. Precision seed meters place individual seeds evenly, while press wheels improve seed-to-soil contact for healthy germination. Advanced pivot irrigation delivers controlled water, encouraging deep roots and protecting crops during dry summer conditions. Within 2 weeks, vibrant peanut shoots emerge from the soil, quickly expanding foliage to capture sunlight for rapid growth. Yellow peanut flowers bloom near the stems, self-pollinating before beginning their unusual underground development. After pollination, flower stems form pegs that grow downward into the soil, where peanut pods gradually develop. Underground pegs swell into fibrous shells, protecting nutrient-rich peanut kernels hidden safely beneath the soil surface. Farmers inspect peanut pods by scraping the hulls, checking inner shell color to determine the ideal harvest time accurately. Specialized digger shaking machines cut pathways, lift entire plants, invert them, and shape away loose soil efficiently. Inverted plants keep peanut pods above the ground, allowing safe curing under warm sunlight without direct soil contact. Harvested peanuts remain in the field for 4 to 6 days, reducing moisture to safe storage levels before collection. Field moisture sensors continuously monitor cured peanuts, ensuring moisture stays below safe limits before long-term storage. Peanut combines collect cured plants, using threshing cylinders to separate pods gently from the vines before the loss. Mechanical separators remove pods, while powerful blowers clear away leaves, stems, and remaining field debris efficiently. Clean peanut pods collect in holding tanks as shredded plant material returns to the field to improve health and soil quality. High-capacity dump hoppers transfer harvested peanuts into drying trailers with perforated floors for efficient four-stage clearing. Trailers connect to stationary warm air blowers, removing remaining moisture to ensure safe long-term peanut storage. Fully cured peanuts travel through enclosed elevators into large steel silos with continuous temperature and humidity monitoring. Shelling machines pass peanut pods through sizing screens and impact rollers, removing outer hulls while protecting the kernels. Vibrating screens and air channels separate broken shell fragments, leaving clean peanut kernels ready for sorting. Advanced optical sorters inspect thousands of kernels every second, removing defective or discolored nuts with precision images. High-quality peanut kernels fill bulk containers for roasting, peanut butter production, and other food processing applications. Continuous industrial roasters develop the rich aroma and flavor required for premium peanut products. Blanching machines gently remove thin peanut skins, exposing clean kernels for high-quality peanut butter production. High-precision stainless steel grinders crush roasted peanut into smooth peanut butter without artificial binders. Automated filling lines package peanut butter into consumer jars, sealing freshness before worldwide retail distribution. Finished peanut butter jars receive airtight seals, labels, and protective packaging before worldwide distribution to retail stores. Next, we explore modern corn farming, featuring advanced soil preparation, automated planting, and GPS-guided harvesting technologies. Deep soil tillage breaks compacted layers, improving root growth, water retention, and soil aeration for healthy corn plants. Large 54-row John Deere planters place seeds at accurate depths and uniform spacing with exceptional precision. Satellite-guided auto track steering keeps planting rows perfectly straight, reducing overlap and improving field efficiency. Polymer-coated corn seeds protect young plants from fungal diseases and common soil pests during germination. Uniform germination creates healthy corn rows that capture maximum sunlight for strong early vegetative growth. High-clearance sprayers apply liquid nitrogen efficiently, providing essential nutrients during rapid corn development throughout the growing season. Tall corn plants produce tassels that release pollen onto developing silks, ensuring full kernel formation. Farmers test sweet corn maturity by checking the milk stage, when kernels contain peak sweetness before starch develops naturally. Field corn dries naturally on the stalk through autumn, reducing kernel moisture for efficient commercial grain harvesting. Advanced John Deere S-Series combines harvest fast corn fields efficiently using modern agricultural technology. Specialized corn feathers snap ears from dry stalks, feeding them into internal threshing systems while leaving stalks behind. Active yield sensors automatically measure grain inside the combine, providing continuous and accurate harvesting data. JD-Link telematics transmit real-time field information, field maps and machine help directly to farm management systems. Unloading augers transfer harvested corn into moving grain carts without interrupting harvesting operations. Grain carts carry harvested corn to waiting semi-trucks for transportation to commercial grain elevators. Semi-trucks unload corn into receiving pits, where bucket elevators move grain into large climate-controlled storage silos. Commercial grain dryers blow warm air through harvested corn, reducing moisture to save long-term storage. Automated moisture sensors continuously monitor drying conditions, protecting kernel quality throughout the entire process. Massive river barges and freight trains transport dried corn to major international shipping ports for worldwide food distribution. Sweet corn processing plants use rubber roller huskers to remove leaves and silk without damaging tender, fresh kernels. Precision rotary blades quickly cut sweet corn kernels from the pod, preserving quality for canned and frozen food products. Bubble water washing removes remaining silk and field debris, ensuring clean sweet corn kernels enter automated blanching systems. Steam blanching preserves natural color, valuable nutrients, and crisp texture before canning or freezing for long-term storage. Automatic fillers place sweet corn and brine into cans before high-speed steamers create strong apex seals. Finished canned corn receives brand labels, protective packaging, and automated palletizing for worldwide distribution. Next, we explore almond farming, including precision drip irrigation, bee pollination, tree shakers, and factory processing systems. Precision drip irrigation delivers water and nutrients directly to deep almond tree roots while conserving valuable water resources. In early spring, almond orchards bloom with white and pink flowers, requiring extensive cross-pollination for successful almond harvests. Beekeepers transport billions of honeybees to almond orchards, providing essential natural pollination for healthy almond production every year. Honeybees carry pollen between different almond tree varieties, triggering fertilization and beginning fruit development across the orchards. Fertilized blossoms develop green outer hulls surrounding hard shells that protect growing almond kernels throughout summer. By late summer, the green hulls split open, exposing the hard almond shells as harvest season approaches. Powerful tree shakers grip each trunk with padded hydraulic arms, preparing trees for efficient mechanical harvesting. Strong mechanical vibrations shake mature almonds from the trees, allowing them to fall naturally onto the orchard floor below. Harvested almonds remain on the orchard floor for several days, reducing moisture before mechanical collection begins. Self-propelled sweepers gather dry almonds into neat windows, clearing away leaves, twigs, and light debris efficiently. Pickup harvesters collect almond windows, removing dust and twigs before loading clean almonds into cold trailers. Heavy trucks transport harvested almonds to commercial hoeing plants, where hulls and shells are mechanically removed for further processing. Color machines use rubber rollers to remove dry almond hulls while protecting the hard shells inside throughout processing. Removed almond hulls are supplied to dairy farms as nutritious feed supplements for healthy livestock herds. Shelling machines crack hard shells carefully, releasing whole brown almond kernels without damage during processing. Grading screens sort almond kernels into standard industry sizes, ensuring consistent quality across every production batch. Laser optical sorters inspect every kernel, removing chip, damaged, or defective almonds with precision airjets automatically. Natural steam pasteurization eliminates harmful pathogens while preserving almond flavor, moisture, and valuable nutritional quality. Continuous industrial roasters develop crisp texture and rich nutty flavor required for premium almond products worldwide. Specialized slicing machines cut blanched almonds into thin flakes for bakeries, breakfast cereals, and dessert production. Vacuum nitrogen packaging protects almonds from light and air, preserving freshness during worldwide retail distribution. Next, we explore modern apple production, including advanced orchards, careful harvesting, water transport, and electronic fruit grading systems. Modern high-density apple orchards use GPS-guided tractors to plant dwarf trees in straight, well-supported rows with high precision. Vertical trellis systems support fruiting branches, maximizing sunlight exposure and improving harvesting efficiency throughout each season. Workers carefully hand-pick ripe apples, placing each fruit gently into padded picking bags to avoid bruising during harvest. Collected apples are emptied into wooden field bins with soft linings that protect fruit during transportation. Field tractors carry loaded bins onto trailers, delivering freshly harvested apples to modern packing facilities. Hydraulic bin dumpers release apples into water flumes, allowing fruit to float gently without impact damage. Water flumes transport apples through washing channels, cleaning surfaces while cleaning the fruit before grading. Automatic monitoring systems control water sanitation, maintaining safe washing conditions throughout the processing operation. Soft rotating brushes clean apple skins before warm air dryers remove remaining surface moisture efficiently. Auto-synchro weighing cups accurately measure every moving apple before electronic grading and final packing operations. Optical sorting cameras capture multiple high-resolution images, analyzing apple color, shape, surface defects, and overall appearance. Near-infrared sensors measure internal sugar levels while detecting hidden rot and fresh browning without damaging the fruit. Computerized sorting lines direct apples into different channels according to color, weight, and quality grade automatically. Robotic vacuum arms gently place selected apples into protected trays, preventing bruising during transportation and storage. Controlled atmosphere storage regulates oxygen, carbon dioxide, and temperature, preserving apple freshness for many months. Lower-grade apples enter hydraulic presses, producing fresh natural juice rich in flavor, nutrients, and natural sweetness. Cross-flow filtration clarifies apple juice before pasteurization, maintaining natural taste and extending shelf life for consumers. Automated bottling lines fill, pack, label, and package juice bottles for worldwide retail distribution efficiently. Next, we explore garlic cultivation, including planting, drying, clove separation, optical grading, and global export markets. Garlic has been valued for thousands of years because of its unique flavor, culinary uses, and remarkable health benefits. Raised soil beds include drainage and soil bed, creating ideal conditions for healthy garlic root development through winter. Specialized bulb breakers separate garlic heads into individual cloves while keeping protective skins intact before planting. Automated garlic planters place seed cloves at uniform depths, ensuring even germination and strong bulb development. Although large farms rely on machinery, many specialty growers still plant premium garlic varieties carefully by hand. During winter, garlic sprouts grow through protective mulch, producing healthy foliage that supports underground bulb growth. Removing flower scapes directs more energy into bulb development, producing larger and higher quality garlic harvests. Mechanical harvesters loosen the soil, lift mature garlic plants, and bundle stalks automatically for efficient production. Harvested garlic cures in forced air drying barns, strengthening protective skins and reducing disease risk before storage. Automatic chopping machines trim dry stems and roots, leaving clean garlic bulbs ready for further processing. High-pressure air jets remove loose outer layers, revealing clean white garlic bulbs without damaging their delicate surfaces. Mechanical sizing servers separate garlic bulbs into jumbo, medium, and small grades for different commercial markets. Automatic splitters separate cured garlic heads into individual cloves while removing dry outer skins efficiently. Pneumatic air peeling systems quickly remove paper skins, producing clean garlic cloves for industrial food processing. Optical color sorters inspect peeled cloves, removing discolored or damaged garlic with precision air jets. Vacuum nitrogen packaging preserves garlic flavor while extending storage life for restaurants and food manufacturers. Dehydration systems dry sliced garlic before grinding it into a aromatic garlic powder for global seasoning production. Global garlic trade connects major producing regions with international food markets through efficient transportation networks. Whole garlic bulbs packed in breathable mesh bags supply retail stores with fresh cooking ingredients every day. We have seen 6 remarkable agricultural products transformed from farm crops into advanced commercial food products. Automation, robotics, GPS technology, smart sensors, and modern factories continue improving efficiency while supporting future global food supplies. Controlled environment greenhouses enable year-round crop production, protecting plants from weather changes while saving valuable water resources. Fresh cucumbers provide hydration, crisp texture, and nutrition directly from sustainable greenhouse farms to consumers. Automated processing lines transform harvested crops into fermented foods with long-lasting culinary value without artificial preservatives. Fermented pickles deliver unique flavor, satisfying crunch, and probiotic benefits enjoyed in many cultures worldwide. Peanut farming depends on precise soil conditions, underground pod development, and dry weather curing before mechanical harvesting. Healthy peanut plants produce dozens of underground pods filled with protein-rich kernels beneath sandy soil. Grinding roasted peanuts releases natural oils, creating smooth and flavorful peanut butter enjoyed around the world. Precision planters place millions of corn seeds at accurate spacing, maximizing soil resources and sunlight absorption. Autumn harvesting collects mature corn grains and moisture fields, reducing losses before storage and processing. Golden corn kernels remain one of the world's most important crops for food, livestock feed, and industrial products. Sweet corn provides natural sweetness, dietary fiber, and antioxidants, bringing valuable nutrition to family meals worldwide. Almond orchards depend on careful farming and honeybee pollination to achieve healthy and abundant nut harvests. Mechanical tree shakers harvest entire almond orchards quickly, reducing labor and improving seasonal collection efficiency. Roasted almonds provide healthy plant fats, crunchy texture, and essential vitamins valued by consumers everywhere. High-density apple trellis systems produce large quantities of sweet red apples for efficient harvesting by workers or machines. Hydro-plume conveyors move apples gently through washing, sanitizing, and sorting while preventing damage during processing. Optical cameras inspect thousands of apples hourly, grading fruit by color, size, shape, and quality standards. Fresh apple juice preserves orchard sweetness while delivering natural hydration, vitamins, and refreshing fruit flavor. Garlic farming combines traditional methods with modern machinery to meet growing global culinary demands. Proper curing strengthens garlic skins, protecting cloves while preserving freshness, flavor, and aroma during transportation. Commercial garlic peeling lines supply ready-to-cook cloves, saving preparation time for restaurants and food manufacturers globally. Combining traditional farming knowledge with modern automation improves crop yields while protecting soil and water resources. Autonomous field robots monitor moisture, crop health, and weeds, reducing chemicals while optimizing fertilizer use. Agricultural drones create infrared crop maps, helping farmers detect nutrient problems and apply precise treatments.
The satellite imagery
Farm
confirms the
management
lower
software
moisture levels in
connects
Sector
satellite
4.
images,
Yes,
field
we need to
sensors,
adjust
and
the
equipment
automated
data for
irrigation
smarter
schedule
agricultural
immediately.
decisions. Artificial intelligence vision systems identify product defects, sorting large volumes of produce with exceptional accuracy. Cold chain logistics transport fresh fruits and vegetables thousands of miles while preserving quality for consumers. Advanced processing and packaging keep grocery shelves supplied with safe, nutritious agricultural products every day. Sustainable farming with renewable energy protects ecosystems while ensuring reliable food production for future generations. Indoor vertical farms produce fresh crops near cities while using significantly less land and water resources. Dedicated farmers and agricultural engineers work together, ensuring abundant harvests from seed selection to final food packaging worldwide. International freight networks transport agricultural products across oceans, supporting global trade and reliable food supplies. Laboratory testing verifies safety, detects residues, and confirms nutritional quality for trusted consumer products. Diverse harvests enrich daily diets with delicious flavors, essential vitamins, and healthy plant nutrients.
Look at the sequencing here. The resistance markers are incredibly strong in this sample.
Yes, the CRISPR activation was successful. This drought-resistant strain is viable.
24-hour autonomous equipment operates continuously, maximizing planting and harvesting efficiency throughout the year. Circular farming converts crop residues into natural compost, restoring soil health while reducing agricultural waste. Digital technology helps modern farmers manage large operations efficiently through advanced mobile tools. Combining technology with environmental care creates sustainable farming that supports future generations. Modern agricultural engineering connects nature, science, and automation to build a resilient global food supply chain. Agricultural technology continues transforming global farming, improving food security, efficiency, and environmental sustainability for the future. AgTech Digital brings you closer to the world's most advanced agricultural innovations and smart farming breakthroughs. From planting fields to automated packaging, technology helps deliver fresh, high-quality food around the world.
This new combine increased our yield by 20%.
Workers whose dedication and
It handles
innovation
beautifully
feed our
in the
growing
field.
population. Thank you for watching this journey with AgTech Digital. Subscribe and join us next time for more farming